Hey guys, it's Dan from Subsystems. Wanted to introduce you or reintroduce you to one of the offerings I have to teach 4-bit programming, really kind of assembly language, as opposed to my 8-bit, which tends to train more in machine language. But this guy, I am holding in my hand the last one I have made. A couple months ago, I went to remake some because I was running low on stock, and this chip was $80. So there was no way to build this. And now this chip, you can't even find it anyplace. And if you do, it's just ridiculous amounts of money. So again, having run out of stock, I thought, well, what can I do to still offer this to people so that they can get educated on how to do assembly language programming? And enter the Smart Response XE. This is the buddy that I've already written in a basic interpreter for. So you can get this and program in BASIC. And then I've converted my 8-bit microcontroller curriculum over to this device. Now I've converted the 4-bit curriculum over to this device. So you'll see it offered on Tindie. If you want one, go pick it up. It's going to do the exact same things as this guy with a couple of added benefits. One, you'll see we've got function keys down here, and we have an LCD display, which is an 8x2. That's going to be mimicked on the Smart Response device. So if I press the power button and turn it on, you'll see you've got the 8x2 display here, and you've got the function keys over here. And the keys 0 through F in hexadecimal all work with the keyboard. So a couple added features under the function, you have the ability to look at the battery voltage. This will tell you what the battery voltage is in millivolts, so that's about 6 volts. That's good. Those are fresh batteries. And it'll also allow you to clear a program. Since my other one is easy, you just unplug the USB port, plug it back in, the program's clear. Here you can hit clear program. I'm going to ask you to confirm it. And now you're back to all zeros or all Fs, all ones in your memory. So the other cool thing about this, and if you've noticed on my Tindie site, hey, this is the same device. Why is this a little bit more expensive? It's because I actually added a speaker, just like this guy has, so that you can make sounds. But it was really difficult. If you crack one of these things open, you see that they actually had a place to mount a speaker, and it gets fed through a transistor. But when you trace it out, the transistor's emitter and collector were reversed. So no transistor is going to work in this, and that's probably why these things were offered without any sound, even though it was built into the printed circuit board. So I have to crack these open, which takes time. You destroy a couple along the way. And then I got to mount the parts. There's 3 parts, a resistor, a transistor, and the transistor can't just mount in its position. You have to mount it a specific way. So it takes a little longer and it has more parts. So you'll see this is just a little bit more expensive than the other ones, but that's why. But you can sample that. Let's write a quick program. Increment key is up here. I also duplicated the increment key down here on the delete key. This is kind of where the enter key is on most keyboards. So it's just a natural place to keep your fingers down here while you're programming. Plus, it's used a lot. So if the increment key goes bad, you can always shift to this one and you'll still be able to write programs. But let's listen to some noise. E is all the extended operations. So because this is only a 4-bit computer, you only have 4 bits of data. So you can only have 16 possible commands. But I extend that. If you use E, you get to use all the other 16s again. And this extends you to about 31 instructions. So we'll enter that into memory 0. Oops, I hit reset. So we'll put E and increment, and then 6. So that's going to make a specific sound. Going to increment. Going to go to E and 7. That's going to make another sound. E6 and 7 are special effects. And then I'm going to jump back to the beginning and play it over and over. So jump is F, and the next 2 are going to be the address of where I want to jump to. So that's 0 and 0. So that's the whole program. Play those 2 special things and then jump back and play them again. So if I go reset, take me back to 0, because I'm going to run from whatever address I start from. If I go to function, up here's run, which means it's just going to free run. It's going to run through the program. Step run means it's going to run step by step, and you're going to advance it so that you can troubleshoot things, or you can look at how the program's executing. You can toggle the beep sound so that when you hit a key on the keyboard, you hit a little beep. And here's where you'll save and load a program. So let's run this one. And it's playing those two tones over and over. So you hit reset, get you back to the main page. So we can save this. If you go to function save, you now have 10 slots. So this is an advantage over the other 4-bit trainer, which only allowed you to save 2 programs. This will let you save 10. So select an area like 5, and it'll load your program into that area. So now if you say reset, and we go and clear our program, confirm, you'll see as I increment through the addresses, they're all F. Nothing's there. But if I say function, load that program from 5, boom, here's my program again. E6, E7, F00. All right. Power knocks the power off. The button on the top, power button, brings it back to life. And that's it. I went through my entire curriculum that's posted and tried all the programs that I have in my curriculum, and they all worked as they should. So I'm going to release this now for anybody who recognized the fact that I am out of my 4-bit trainer. Now you have the opportunity to pick one of these great gadgets up and continue to do your 4-bit training exercises. All right. Thanks a lot, guys, for listening. I'll see you soon.